So I hope that you have finished answering all the 10 questions within this 15 minutes. So let us try to see what are the answer, or let us see the solutions of these 10 questions. So this question paper is actually a little bit tough questions, or you can say it is from medium to tough. That is the difficulty level of these questions. Okay. And also if you are interested in watching these technical assistant videos, or if your friends are interested in, please do share these videos. Okay, so the first question is, it is actually a match the following type of question, but it is very simple compared to the other match the following types. So here there is a set of PQR and there is a set of 1, 2, 3. You have to match this PQR with 1, 2, 3. The option P is shift register, Q is counter, R is decoder. First one in this column, 1 is frequency division, 2 is addressing in memory chips, 3 is serial to parallel data. Okay, so from this options in the second column, it is very clear that serial to parallel, we have always seen these terms, parallel to serial or serial to parallel, always with shift registers, right? So we can match P with 3 directly. Now moving on to the next two options, Q is counter. Counter we generally use to set the count of dividing the clock frequency of the crystal oscillator. For all these purposes we use counters. We can use counters actually. So you can match counter with frequency division. And the last one is decoder. Yes, we use decoders for decoding the address in the memory chips of microcontrollers or any memory chips we can use. Okay, so this is actually the match for this match the following. I have not included the option. The correct answer is actually option A is the correct answer, which is P is matched with 3, Q is matched with 1 and R is matched with 2. Okay, so this is the correct option for your match the following or your first question. Correct answer is option A is the correct answer. Okay, next question is from analog electronics. The question is from op-amp session. If the op-amp in the figure is ideal, V out is dash. We need to find what is the output voltage. Okay, we have been given a ideal op-amp or operational amplifier in which there is a negative and positive terminal and two voltages are connected to both negative and positive terminal. Now we need to find what is the value of voltage coming to the negative terminal and the positive terminal. Okay, so we'll call the voltage coming to the positive terminal as V plus, and V plus is equal to, you can see there are two resistors here, and this 3 volt, this voltage is 3 volt. Okay, so this 3 volt applied will be getting divided across these two resistors, and you can apply voltage division there. So V plus will be actually equal to 8 by 1 plus 8 into 3. Okay, that is, there is one 8K here, there is 1K here, and this 3 volt is getting divided between 8K and 1K. So according to voltage division, you can apply 8 by 1 plus 8 into 3. This is 9. So 8 by 9 into 3. So you can write it as 8 by 3 volt, right? Now, when you are dealing with ideal operational amplifiers, we know that there is a virtual ground concept here. So whatever voltage is coming in V plus will be the voltage in V minus also. So we can say this is equal to V minus, right? So it is again equal to 8 by 3 volt. Now we have V minus, or the voltage coming to this negative or the inverting terminal is 8 by 3 volt, and now we can apply here Kirchhoff current law here, okay, KCL in this particular node, and we can write the equation there as, or we can simply we can say it is nodal analysis. So we can write V minus 2 volt by 1K, or you can simply write all the resistors are in K, or simply you can write it as 1. Okay, this voltage across this inverting terminal, I have just bubbled it. Okay, it is V minus 2 volt by the resistance is 1K. Okay, Now plus V minus minus V out by 5 is equal to 0. Now here there is V minus volt here. Here the voltage is V out and the resistance across it is 5. So this is the nodal analysis equation. Okay. And from this we will get the relation V out is equal to 6V minus minus 10. If you solve this, you will be getting V out is equal to 6V minus minus 10. Okay. Now, we already have the value for V minus, or simply we can substitute it in the above equation and also find the value, because we already have the value for V minus, right? So here, I'll write it above. V out is equal to 6 into 8 by 3 minus 10. We can cut it as 2. 8 is 16 minus 10 is 16 minus 10 is 6 volt. Okay. So V out you have obtained as 6 volt is the output voltage of this operational amplifier. So how to do this question? First we need to find what is the voltage coming to the inverting and the non-inverting terminal. First we will start with non-inverting terminal by finding what is the voltage coming to the non-inverting terminal by applying voltage division with this 3 volt. Then we will get the value, and which will be same as that of V minus. Then we will apply a nodal analysis in this part along this resistor and the feedback loop. Okay, so then we will be getting the value of V out, which is equal to 6 volt. Correct answer is option B. 6 volt is the correct answer. Question number 3 is from communication systems, that is from analog communication system. Let M of t is equal to cos 4 pi into 10 raised to 3 t be the message signal. Okay, this is message signal, and C of t is equal to 5 cos 2 pi into 10 raised to 6 t be the carrier of AM. The modulation index is 0.5. Find total sideband power to carrier power ratio. Okay, so you need to find this ratio, and the only equation you actually need to solve this question is the total sideband power PSB, okay, is equal to M square PC by 2. If it is separately, you are taking the sideband powers for individual sidebands, then it is equal to M square PC by 4. But the total sideband power is a sum of those two, that is M square PC by 4 plus M square PC by 4, which will be equal to this. Okay, so this is the total sideband power is equal to M square PC by 2. Now, what you need actually, you need PSB by PC. Okay, so simply you can take this to the denominator and you will be getting M square by 2. Okay, what is M? M is 0.5. So 0.5 into 0.5 by 2. You can write 0.5 as 1 by 2. So 1 by 2 into 1 by 2 into 1 by 2. That is equal to 1 by 8. Okay, so the correct answer is 1 by 8 is this ratio. Okay, so the answer for this question is option D, which is 1 by 8. Okay, so again, for solving this question, you should know that the total sideband power is equal to M square PC by 2. Okay, please note this down. Anyway, the correct answer for this question is 1 by 8 is the correct answer. Next question, which is question number 4 actually, it is from electromagnetic theory. Okay, if the E field for a uniform plane EM wave or electromagnetic wave in a perfect dielectric medium is Ez of t is equal to 10 cos 2 pi into 10 raised to 7 t minus 0.1 pi Z volt per meter. Okay, so while discussing the electromagnetic theory basics, that is about the EM waves, parameters and propagation, a separate video I have done. In that I have explained how the E field equation and how the H field, that is, this is electric field equation. Now the magnetic field equation also you can write. So how these equations has their basic forms. Now you should know that basic form to answer this question. Anyway, we'll go into that. So this is the electric field equation of this uniform plane electromagnetic wave. Okay. Then the velocity of the traveling wave is dash. We need to find the velocity of the wave. Okay. So just know that the standard equation for the E field is E0 cos this 2 pi into 10 raised to 7 is actually omega t minus beta z volt per meter. Okay, so this is the standard equation. Okay, now from this you will get omega. What is omega? This is the standard equation which is taking this form due to the various values of omega, beta and E0. Here E0 is 10. Omega is 2 pi into 10. Okay, it is 2 pi. So omega is 2 pi into 10 raised to 7, right? Yes. Now beta is 0.1 pi. Now you need to find what is the wave velocity. And the equation for finding that also I have discussed in the video. So these type of videos for electromagnetic wave also, and also for antenna, for ASK, PSK, and also for this transmission lines. All these videos I have done especially for exam basis. All the required equations only I have included in those videos. So please do watch all those videos also, not just do the mock test alone. So side by side you have to see those videos also, so that you should get the equations thorough. So anyway, this is the general equation for the electric field. Okay, and this is the, from this you will get omega is equal to 2 pi into 10 raised to 7 and beta is equal to 0.1 pi. Now you need to find what is the velocity, and the equation for finding velocity is velocity v is equal to omega by beta. This also we have discussed. Okay. Now I'm going to remove this. Velocity v is equal to omega by beta. What is omega? Omega is 2 pi into 10 raised to 7 by 0.1 pi. Now this pi and pi you can cancel out. And 2.1 you can write it as 10 raised to minus 1. And if you take that to the numerator, it will be 10 raised to 8, right? So this is the answer for this question. 2 into 10 raised to 8 meter per second. And in the options you can see there is a 2.00. That is the answer. 2.00 is nothing but 2. 2 into 10 raised to 8 meter per second is the velocity of the wave. So the correct answer is option B is the correct answer. The next question is from digital electronics. It is actually from number systems. The range of signed decimal numbers that can be represented by 6-bit ones complement number is dash. Okay, so the equation for finding this is, the range actually varies from minus 2 raised to n minus 1 minus 1 to plus 2 raised to n minus 1 minus 1. Here n is 6. Okay, so it is from the range minus 2 raised to n minus 1 is 2 raised to 5 minus 1 to plus 2 raised to 5 minus 1. 2 raised to 5 is 32. 32 minus 1 is 31. So it is from minus 31 to plus 31. Okay, so this is the range. So this much of numbers you can actually represent with a 6-bit ones complement number representation. Okay, so the correct answer for this question, I have not included the option. The correct answer for this question is actually option A is this range, that is minus 31 to plus 31. Okay, so correct answer is option A is the correct answer for this question. Next question is from electromagnetic theory again. Here the question is the depth of penetration of EM wave. This is actually regarding the skin depth. Okay, so the depth of penetration of EM wave in a medium having conductivity sigma at frequency 1 megahertz is 25 centimeter. The depth of penetration at 4 megahertz is dash. So this is actually a relation between depth of penetration or skin depth and your frequency. So the relation between penetration or depth of penetration and frequency is delta is proportional to 1 by square root of f. You can write the relation between these two depth of penetration and this frequency says delta 2 by delta 1 is equal to square root of f1 by f2 it is actually. Okay. Delta 2 is the new depth of penetration or skin depth we need to find. Delta 1 is already given as 25 centimeters. F1 is 1 megahertz. F2 is 4 megahertz. Okay. Since it is following this inverse relationship and that to square root. So you are getting this relation. Okay. So if you want to note this down, you can note it. Now delta 2 we need to find. Delta 1 we have it as 25 centimeters. F1 is 1, F2 is 4. So it is 1 by square root of 4. Okay. That will be equal to 1 by 2. So we'll get delta 2 is actually 1 by 2 times of delta 1 which is 25 centimeter. Now 1 by 2 of 25 is 12.50 centimeters. Okay. So this is the answer for this question. Again, I have not included the option. The correct answer is option B is 12.50 centimeters. Okay. So when the frequency is changing from 1 megahertz to 4 megahertz, the depth of penetration is actually decreasing from 25 centimeters to 12.50 centimeters. Okay, correct answer for this question is option B is the correct answer. The next two questions are from digital electronics. The first question is, without any additional circuit, 8:1 mux can be used to obtain dash. I have directly included the answer here. See, for a 8:1 mux, we know that 8:1 means there will be 8, 4, 5, 6, 7, 8. So totally 8 input lines will be there. There will be 1 output lines. That is called a 8:1 mux. There will be 3 select lines, right? So here you can write 8:1 mux as 2:n:1. Generally we can write this mux in the form 2:n:1. Here n is the number of select lines. This is 8:1. So you can write 2:3:1. Right. So 2:3:1 means it is 8:1. And here 3 select lines are there. And if it is a 2:n:1 number of or mux, you can implement all functions of this n variable. Here it is 3. So you can implement all n variable functions and also some portion of the n+1 variable also. Okay. That is a case. Okay. Here n is 3. So you can implement all functions of 3 variable and also some functions of n+1, that is 3+1, which is 4 variable. You cannot implement all functions, all Boolean functions of using 4 variables, but you can implement some of them. But anyway, you can implement all 3 variable functions without having any additional circuitry. The correct answer is all function of 3 variable and some but not all of 4 variables. Next question. The number of distinct Boolean expressions of 4 variable is dash. Okay, so that is how many number of Boolean expressions you can have with 4 variables. That is a question. The equation is you can have 2:n number of Boolean expressions. Okay. 2:n number of Boolean expressions you can have. Now, what is 2:n? 2:n is 2:4, which is 16. And you can have 2:n means it is 2:16, which is 65536. This much of distinct Boolean expressions you can have with 4 variables. If you have 4 Boolean variables, you can have this much distinct Boolean expressions. Okay, correct answer is option D is the correct answer, 65536. Okay. The next question is again from analog electronics. If AD, that is a differential mode gain of the op-amp. Okay, so this question is regarding op-amp. So if differential mode gain AD is 48 dB and AC, which is a common mode gain, is 2 dB, CMRR is dash. The equation for finding CMRR is, general equation is CMRR is equal to differential mode gain by common mode gain. But if you want to find in dB, then you can write it as 20 log 10 CMRR is equal to 20 log 10 AD minus 20 log 10 AC. So here AD and AC are not dB values. If it is directly given as some ratios or some numbers, you have to put that here. But here the values are directly given in dB. So you have these two values here. See, 20 log 10 AD is 48 and 20 log 10 AC is 2 dB. Okay. Since the values are given in dB, the values are directly given as 20 log, that is, this much value is given as 48 and this much value is given as 2 dB. Okay. So the dB values of differential mode gain and common mode gain is given to you. That is 20 log 10 values is given. So you have to simply, to find the 20 log 10 CMRR, you simply have to take the difference. Okay, 48 dB minus 2 dB. That is nothing but 46 dB. Okay. It is very simple question. You just have to understand that since it is given in dB, you have to take the difference simply. You don't have to take the ratio or anything. You just have to take the difference between these differential mode gain and common mode gain. And the answer you will be getting is C, which is 46 dB is the correct answer. Next question is from C language. Okay. Which of the following, this is a very simple question. Which of the following is a logical NOT operator? In C programming, the logical NOT operator is given by an exclamation mark. Okay, now what is this option? The option B is double ampersand and it is indicating logical AND. Okay, this is not any operator and all of this also not the answer. The correct answer is option A is the correct answer. Okay, so these are the questions which I have included in this video. So I hope that you found this video useful for your preparation. I've tried to include maximum variety of questions from different subjects. Anyway, the most important subjects are analog electronics, digital electronics, electromagnetic theory, communication systems, and all these are the most important subjects, and also network. So maximum questions I've tried to include from this area. Okay, so I really hope that you found it useful. If yes, please do give it a thumbs up and also share these videos maximum with all of your friends who's preparing for the technical assistant examination. That can be for any location, not just HSFC or VSSC, for all locations. And if you want more videos, please do subscribe to the channel. Thanks for watching and keep on watching.